Hello to you all, our good viewers at BACSEC Science Education Consultants. We have our online classes, online coaching, career guidance, and then guidance and counseling. We are ready to serve you everywhere you are and whatever you are doing. And simply go to our YouTube channel and click subscribe button and be able to get notified anytime we upload. We are back with A-level mathematics. Previously, I had introduced a topic of work, power, and energy, where I talked about work and we were able to calculate some few calculations. We defined work as a product of force and the distance moved in the direction of force, where we proved and said there is no work done when the force has not caused a displacement. We talked about different situations where work is done against gravity. We talked about a work done when a force is given as a variable in terms of displacement. And today we shall switch on to work done when a force is given as a vector. Here we are talking about if the force is given as a vector quantity, then to get the work done, we dot the force vector and the displacement vector. An example is like when you have the force being expressed as F1, maybe small f1 in the direction of I, then F2 in the direction of J, and then F3 in the direction of K. And then we are given the displacement as a vector also. We can say S1 in the direction of I, then plus S2 in the direction of J, and then S3 in the direction of K. Then we say that to get the work done, it will be the dot product of F and S. This dot means F and A, the dot product. Then we dot them in column form where we have F1, F2, F3, and then dot S1, S2, S3. And this simply gives you dot this, and then you get F1, S1. You add, when you dot J and J, that is F2, S2, and then you add F3 with F3. And this is a scalar quantity, we call it joules. That will be the work done. An example. Well, we are told that a constant force F acts on a particle as it moves along a straight wire from point A to point B. If I can sketch, there is a force that is causing a particle to move from point A to point B. They are saying the position vector of A. The position vector, of course, is always from the origin, so we can create an origin here and then say that this vector OA, which is expressed as I and then negative j, we can write it in column form as negative 1 or 1 negative 1. And then this is vector OB, the position vector of B, and it is given as 2, 2. That is vector OB. And then they are saying the force F is given by 2 in I direction and 1 in J direction in newtons. We said that if the force is expressed as a vector, then the work done equals the dot product of force and the displacement. If the body is moved from A to B, then we are required to look for the vector AB. And to get vector AB, you move from A to O and then O to B. So we shall say vector AB equals AO plus OB. But AO is the negative of OA, so we shall have negative OA plus OB. And this simply gives you OB, which is 2, 2 minus OA, which is 1, negative 1. And this is 2 minus 1, which is 1, 3. So that is the displacement. To get the work done, we shall say it is equal to F dot AB. It is equal to F dot AB, which is 2, 1 dot 1, 3. And this simply gives you 2 times 1, which is 2, and then 1 times 3, which is 3, and this is 5 joules. And therefore the work done is equal to 5 joules. That is it. Right from where we started, work has been calculated for situations in which the force has been in the same direction as the direction of motion, or directly opposite to the direction of motion. However, this will not always be the case. For example, we can have a situation where a body is placed on a horizontal surface and it is being pulled by a string which is placed over the shoulder of a person and pulling it. This body will be able to move on a horizontal surface, but the force will be acting in the direction of the string. This can be illustrated as below. We have a box. There is a force acting on it in that direction. It is placed over someone's shoulder. And this box has been able to move from position A to position B. It is now here through a distance of S meters. This string is inclined at an angle theta to the horizontal, and there is a constant force F. The constant force F can be resolved into 2 components which are perpendicular. That is the vertical and the horizontal component. The horizontal component passing through theta is F cos theta, and the vertical component is F sin theta. The horizontal component, therefore, is the one that is responsible for the motion of this body, as F sin theta acts in opposite direction as the direction of motion. Therefore, we shall conclude and say that F cos theta is responsible for the motion. And therefore, in this case, we shall say the work done is equal to the force times distance, but the force that does work is F cos theta, and then times the distance S. And we call this one the force which partially does work. It is not the whole of this force that has done is a fractional force of the original force that has done this work. Examples. We have been told that in this example, the force continues to act as the particle is made to move along a straight line path from A to B. This force is acting on this particle and makes it to move from point A to point B at an angle of 30 degrees. And we are required to compute the work done in each case. Solutions for part A. For part A, we said that if the force acts at a certain angle, then the work done is equal to the force times cos of theta, then times the distance moved. We have the force as 6 newtons. We have the angle at 30 degrees. And then we have the distance moved as 3 meters for each case. And this will actually give us cos of 30 is root 3, and then you multiply 3. This actually gives us 18 root 3 joules. Cos 30 is root 3 over 2, and so we have root 3 over 2 here, and this actually gives us 9 root 3 joules. That is the work done in part A. Then for part B, we know that work done equals F times the distance cos of theta, and this simply gives us the force as 10 newtons, the distance moved is 3, and the cos of 120 is same as negative cos of 60, which is actually negative a half, and this is this goes with this, and it gives us a negative 15. What does a negative sign actually imply? Negative sign implies that the force and the motion is in opposite direction as force. If this force is towards this side, then the motion is towards the other side. Thank you very much. For the activity, I refer you to Understanding Mechanics by AJ Sepra and DWS Thorning. Check the exercise 11E and 11D. Be able to look through all those questions one by one, compute, compare yourself, and send us a feedback as well on our timeline, BACSEC Education Consultants. Please subscribe to our YouTube channel and be able to pass your O-level and A-level sciences. Thank you very much.